So welcome back with our discussions on input output units of PLC. So in this lecture we will see what is the particular operation of an output unit. Normally you see the output from the input output unit, that is the basic output what you are getting at the out of the CPU, and then within the PLC the input output unit will be digital signal with a level of 0 volt and 5 volt. However, we need to condition that signal properly before giving it to the external terminal of the PLC. So this you should be very clear about. What is that? Okay. What I want to say, if suppose this is the actual output within the PLC, okay, you have got channel 1, channel 2, channel 3, channel 4, channel 5 and likewise. So here what is the maximum signal that you can get is 5 volt, right? But this is not actual the external port that you are getting at the PLC housing. If this is the actual PLC housing, then here at the output terminal 1, output terminal 2, output terminal 3, output terminal 4 and output terminal 5, like that. These are the terminals which are accessible by the user. This particular thing is not accessible by the user, and at that level the max digital signal is 5 volt. So here you are getting a proper digital signal, standard digital signal. However, before connecting this to this, you need to go for signal conditioning. Now, you need to go for does not mean that you are needed to go for that. The manufacturer has already done that. But before using the PLC, you should specifically know what actually the manufacturer has done. Whether in this signal conditioning unit he has put a relay, or he has put a transistor, or he has put a triac, that you should know very clearly. And whenever you are able to know that he has put a relay or the transistor or the triac, be very sure about the specifications that is available for you as an user at the output. Especially about current, be very sure about this. Otherwise you will definitely damage your PLC while doing some or other operation. Now see here that what we can have, the output channel may be 24 volt 100 milliampere switching signal, right? It can be a DC voltage of 110 volt 1 ampere, or you can have the output 240 volt 1 ampere AC, or you can have 240 volt 2 ampere AC if the output channel is triac enabled. Triac is a particular powered semiconductor device. So you can see that this PLC have so many facets. इसके इतने सारे अलग अलग प्रकार हो सकते हैं, रूप हो सकते हैं कि आप सोच भी नहीं सकते हो. ये समझो. You do not go to an industry with the basic idea. मैंने एक PLC में काम किया था, छोटा सा था, जिसमें 6 इनपुट थी, 4 आउटपुट था, 6 इनपुट थी तो 12 आउटपुट होगा, और उसमें 24 वोल्ट इनपुट और आउटपुट मिलती थी. ये नॉलेज लेके जाना ठीक नहीं होगा. नॉलेज ये चाहिए आपको कि दिस PLC has a capability of computation, it has have got the logic decision capability, the input can be of this much type, the output can be of this much type. This you should know. Then yes, you are now allowed. Now you see, if we are talking about small PLCs or the brick PLCs, then all the outputs can be of one type. There is no doubt. It can be of 24 volt DC 1 ampere. It is a very typical specification. However, when you are having modular PLCs, you have large range of outputs that can be accommodated by selecting the proper modules that you want to use. Okay, if for certain application you need 5 ampere output at maybe 5 volt, in other application you need to have an AC output at 1 ampere, you can choose different modules that you can attach to the PLC. Just like you're topping in the pizza, you can attach these modules to the PLC in order to get the proper output that you require for your specific application. Now, the output channels enable the PLC outputs to be available in form suitable for direct connections to external circuits. Now you see, in order to do that, outputs in the PLCs are of specific type. One is the relay type, other is the transistor type, and third one is the triac type. The first one is the relay, transistor and triac. Be very sure to remember these three specific terminologies. With the relay type, the signal from the PLC output is used to operate a relay and is able to switch currents of the order of a few amperes in the external circuit. In my very first lecture, I have shown what is the basic operation of a relay. Through that, I am 100% sure that you are now able to envisage that the signal that is coming out from the CPU of the PLC, after initial signal conditioning, it is given to the solenoid of the PLC. The relay, the external relay. It will be given to the solenoid part of the external relay, so that the PLC signal can activate the solenoid. The PLC signal can simply activate the solenoid. Now, when the solenoid is activated, the NO, NC and common terminals are available to you that you need to employ for the final I should say this connection. Now generally when we are connecting a relay to a PLC output signal conditioning element, we do not have the NC connection. We are normally having the NO and common available. Okay, we will see these things in further detailed manner in later course of this lecture. The relay allows small currents to switch much larger current, because in order to activate that solenoid you require a small amount of current. However, at the output side, that is the common terminal, NO terminal and NC terminal side, you can handle a very large amount of current. So here you can see that the small current capability which is inherent with the CPU of a PLC is no factor. You can handle very large current with the help of that. The purpose of PLC will be only to generate proper logic. Definitely the relay isolates PLC from the external circuit. However, the relays are relatively slow to operate. Relay outputs are suitable for AC and DC switching. You can apply both AC and DC if we are using a relay as an output device. Now they can withstand high surge currents and voltage transients. These are basic characteristics of relay itself. Next, you can have transistor type of output signal conditioning element. Now, here you are actually using a transistor to switch current to the external circuit, right? Rather, I should say to switch current through the external circuit, because here you use actually open collector configuration of the transistor. Now, if we compare the transistor type with the relay type, then it is very sure that transistor types, they offer a very fast switching action with respect to the relays. However, whenever we are using a transistor, it is strictly for DC switching. Remember, transistors cannot be applied for AC switching operation. And if some overcurrent or high reverse voltage is there, the transistor will be simply destroyed. Therefore, you need to give proper protection. You use either a fuse or some built-in electronic protection is already given. Opto-pipe isolators are invariably used to provide necessary isolation. Finally, you have got triac outputs also. So these three types, one is relay, the other is transistor, and finally is triac type signal conditioning. With opto-isolators for isolation, triacs can be used to control external loads that are connected to AC power supply. Because you know triacs can conduct in both the direction, therefore they are applied for AC applications. It is strictly for AC operation and can be destroyed by overcurrent. Okay, so therefore fuses are virtually always included to protect such output. If you are sure that your PLC is having track output, be sure to use fuses. Otherwise, if overcurrent is there, your track will be immediately destroyed. So likewise, in transistor type of PLC, if transistor type of PLC you are applying a solenoid sort of load, right, then there is always possible that a back EMF, when the solenoid is closed, then a very heavy back EMF is generated across the solenoid, and accordingly a high amount of current will go back to the transistor, which may damage the transistor. So under that circumstances, you need to connect an anti-parallel diode, which is always called as that flywheel diode or flyback diode, that you need to connect anti-parallel to the solenoid. So you see, I am not discussing all these things in detail because I hope all of you are from electronics background or industrial automation background or electrical engineering background. Therefore, I am not elaborating the terms like back EMF and flywheel or freewheeling diode and these sort of things. So if you have any confusion, please let me know. I can, but under that circumstances, you need to either let me know personally or you need to come to know at my lab so that I can enable you to let these things under your brain. Now comes a very important concept, and rather the most important concept when we are connecting external devices to PLCs. You can see, initially first we will talk about input module and then we will talk about output module. There are two terminologies. One is sourcing and other is sinking. I will not elaborate in detail, that might confuse you. I will simply use two statements, right? Please be very careful. The terms sourcing and sinking are used to describe the way कि किस तरह से DC devices PLC के साथ connected है. Now you see, when sourcing operation is there, an input device receives current from the input module. The input device receives current from the input module. However, for sinking, the input device supplies current to the input module. Are you getting the point? This is very clear. In case you see, you are using input module. This is the input module, right? This is the input device and you are using input module as a source. So then the current will be flowing from input module to the device. So when the switching will be on or off, when the switching will be on, the current will be able to flow. When it will be off, the current will not be able to flow. Accordingly, the logic decisions are taken inside. However, input module cannot generate current. For that, you have to already put the positive current inside the device from a dedicated terminal. And this is definitely the VCC. If you want to just find a proper analogy with the electronics that you have already gone through, this is your VCC and this is your ground. And here again, if I am talking about the input module, when it is operating as a sink, then this you can think this is the input device through which the current is passing. In this case, the one terminal of the input device is connecting to the source, and in this case one terminal is connected to the ground. So from source, current is passing through the device. When the device is on, the current will pass. When the device is off, the current will not pass, and the current will flow through the input module and it will be going to ground. सिंक मीन्स थ्रू विच यू कैन सिंक. आप घर पे बोलते ना किचन में सिंक रहता है, उसमें से पानी क्या होता है, सिंक होके जमीन पे पहुंचता है. सो अकॉर्डिंगली here you can see the device is acting as the sink and module is acting as the source. Here what you can see, the module is acting as the sink, device is acting as the source. Now in output module, while we are talking of sourcing, the load receives current from the output module. I think it is wrong. Here it should be output module, it should be written. I think I have drawn it in wrong manner, but it should be output module. Okay. So here the load is receiving the current from output module, while in syncing the load is putting current into the output module. So in this case the output module is working as a source, and in this case the output module is working as a sink. If output module is working as a source, then definitely the load is sink condition, and if the output module is working as a current sink, then the load is at source condition. So please be very sure about this. Now you may ask one question, which one we should use? You should use according to the sensor that is available, or according to the sensor that has to be applied. The sensors, whatever sensors you are using, that can be either sourcing type or sinking type. So it is the application demand which will ultimately decide, and accordingly you must try to find the PLC. However, nowadays there are PLCs in such cases we can use the terminals either as sink or as source. But even if the facility is given in the PLC, remember that either all the terminals will act as sink or all the terminals will act as source. You cannot make like that one of the terminal is sink, other of the terminal is source. This you cannot do even under such circumstances if the PLC allows you to choose between a sinking or sourcing terminal. Now another terminology which is there after this sinking and sourcing, which is PNP and NPN. Now you see, I am talking of very practical purposes. This, whenever you talk of any sensor, maybe you are talking of an proximity sensor. Such sensors are having three-wire connection. One is the supply, other is the ground, and the final one is the signal. So such type of sensors can be PNP type और NPN टाइप. आप आज मार्केट में जाइए और जाने के बाद बोलिए कि मुझे एक प्रॉक्सिमिटी सेंसर चाहिए, तो आपको ये पूछेंगे PNP चाहिए कि NPN चाहिए. Now you should know that what is the difference between this PNP and NPN. Now you see that such type of sensors are solid state. Solid state means that some sort of solid state electronic component has been used within the sensor, and this is invariably transistor. Now it is the transistor that is used to switch the output of the sensor upon detection of an object. So proximity sensor, आप लोगों को पता है कि proximity sensor जो भी है, इंडक्टिव हो, कैपेसिटिव हो, अल्ट्रासोनिक हो और फोटोइलेक्ट्रिक टाइप हो, जब उसके सामने कोई चीज आती है, इफ इट इज एन इंडक्टिव सेंसर, वो ही कैन सेंस non-metallic object or non-metallic object. Capacitive sensors can only detect non-metallic object. You can have ultrasonic sensor which can detect any object. We can have photoelectric sensor, because whenever some particular object will come in front of that photoelectric sensor and it will stop the light that is reaching the sensor, or if it is an IR type one, then the IR sensor, IR signal that is being sensed, there is a transmitter and a reflector embedded onto the same sensor housing assembly, and whenever some object is there, then the IR signal will be reflected back from that object, and it will activate ultimately a transistor. Whenever object is detected, a transistor is activated. Now this transistor is the responsible factor to switch the output of the sensor. Okay, now two specific type of sensors are available, therefore PNP and NPN. ऐसा क्यों? ट्रांजिस्टर PNP हो सकता है या NPN हो सकता है. So accordingly the output of the sensor is PNP or NPN type. Now the difference is a result of the internal circuit design and type of transistor used. Now you see, a key point to observe is that PNP or NPN has nothing to do whether the sensor is normally open or normally closed type. ये बहुत इंपॉर्टेंट है, कंसेप्ट है, ध्यान में रखिए बच्चों. आपकी सेंसर नॉर्मल ओपन हो सकता है या नॉर्मल क्लोज हो सकता है। नॉर्मल क्लोज मींस, नॉर्मल क्लोज का ये मतलब है कि जब कोई ऑब्जेक्ट नहीं रहेगा, ये है उसकी नॉर्मल कंडीशन। ये कंडीशन में आपके आउटपुट आपको क्लोज मिलेगा। दैट मीन्स इफ योर that this thing is I should say your signal wire, अगर आपने 12 वोल्ट सप्लाई दिया, ग्राउंड को लगाया आपने, क्योंकि उसमें 3 वायर रही थी, वन विल गो टू 12 वोल्ट, वन विल गो टू ग्राउंड एंड वन इज द सिग्नल। सो आपने 12 वोल्ट दिया, ग्राउंड लगाया और आपके सिग्नल टर्मिनल आपके पास अवेलेबल है। अगर ये नॉर्मल क्लोज टाइप है तो ऑब्जेक्ट नहीं रहा, ऐसे सिचुएशन में आपको आउटपुट में 12 वोल्ट मिलेगी, यू विल बी गेटिंग ए हाई एट द आउटपुट। अगर ऑब्जेक्ट आ गया तो वहां पे वोल्टेज आपका लो हो जाएगा। सो अकॉर्डिंगली यू नीड टू डिसाइड आपकी सिचुएशन क्या रहेगी, आपकी पीएलसी को क्या चाहिए, अब वो कौन सा सिग्नल लेगा, दैट यू नीड टू डिसाइड। नाउ यू सी एनपीएन और पीएनपी टाइप, पीएनपी जो सेंसर है वो एनओएनसी दोनों ही हो सकता है उसके आउटपुट, एनपीएन जो है वो भी आउटपुट एनओएनसी दोनों ही हो सकता है। PNP sensors are also called sourcing sensors because actually they source positive power to the output model. PNP सेंसर जो रहता है वो सोर्सिंग वाला होता है, NPN सेंसर जो रहता है वो सिंकिंग वाला होता है, बिकॉज दे सिंक ग्राउंड टू द आउटपुट। आउटपुट सिग्नल को ग्राउंड की रास्ता दिखाने वाला सेंसर होता है सिंकिंग सेंसर। अभी देखिए, आई थिंक आई शुड स्टॉप हियर एंड आई विल कंटिन्यू विथ नेक्स्ट लेक्चर with the rest of the topics. Thank you.